So we are now looking at example 5.4. An experiment is carried out by tossing a fair coins 3 times, and y be the number of tails obtained. So this is a fair coin, yeah? So we want to construct a probability distribution of y. So again, probability distribution is only these 2 columns. The other 2 is for part B. Okay? So now, what are the possible value of y? You toss the coin 3 times. How many heads that you can get? How many tails that you can get? What are the possible value of y? 0, 1, 2, 3. So, we have possible y is 0, 1, 2, 3. So y take value 0, 1, 2, 3. Then what is the probability of y equals 0? How can y equal 0? How can I get y 0? Number of heads, number of tails 0 means? Sorry? 0.5. So but I'm asking you how you get that. How can you have y equals 0? All 3 are head. So head, and because they are fair, alright, so you have half. So probability of, maybe I put it this way. Probability of y equals 0 is actually probability of H. Right? So then this is half, and half. So that's why you have 1/8. So then this is 1/8. Okay? How can you have 1? How can you have 1? Tail, head, tail, head, and head, tail, right? So therefore, this is 1/8, and you have 3 times of 1/8, right? So you have 3/8. Okay, then how can you have a 2? Probability of y equals to 2 is tail, head. Alright, you have 2 tail. Sorry? H, tail, and tail, head, tail, right? So again, this becomes 3/8, right? Okay, then your y equals to 3, that is straightforward. That is tail, and tail, right? So you have 1/8. So 1/8, right? So then this is my part A. Part A is only for these 2. I don't need the other 2, okay? So find the expected value of and the variance of y. Okay, so I want to find expected value. I need to multiply the y with the probability of y. So when I multiply this, I have 0. Then I have 3 over 8. Then 2 times this, I have 6 over 8. Then 3 times this is 3 over 8. Alright? Then remember EY is sum of y times probability of y equals to y. So that is when you sum, what do you get? Three over 2. Sure. 12. Right, 12 over 8. 3 over 2. 12 over 8. Okay. Then I want to find variance of y, that is ex squared minus ex, and you take a square, right? So ex squared is, I multiply this with your y squared, then I have a 0, then this is 3 over 8, then 2 squared is 4, 4 times 3 is 12 over 8, then 9, right? 9 times 1 is 9 over 8. Okay, so what is my, sorry, wrong. What is supposed to be y, right? So what is my EY squared? Three. So EY squared. So become 3 minus 3 over 2 squared. So you get 3 over 3 over 2 squared. 3 minus 3 over 2 squared, you get 3 over 4. Okay with that? I don't expect to write this actually. Okay. So now, what about example 5.5? Let Z be the random variable with the probability mass function as follows. This is the mass function. Then can we find EZ? EZ is Z multiplied with the probability, right? So it's 2 times, sorry, it's negative 2 times 1 over 9 plus negative 1 times 2 over 9 plus 0 plus 2 over 9 times 2, right? So what do you get? Zero, right? Okay, then the question is, can we get EZ plus 2? How can we get Z plus 2? We have two methods. One method is, remember, is sum of Z plus 2 times probability of the Z, right? So now, minus 2 plus 2 is 0, then times 1 over 9. Okay? Then minus 1 plus 2 is minus, oh, sorry, plus 1 already, right? Okay? Plus 1 times, then this is 2 over 9. Then 0 plus 2 become 2 times 4 over 9. And 2 plus 2 is 4 times 4 over 9. So then we get 2 plus times 4 is 8. 4 times 4 is 16. 16 plus 8. 24 plus 2. Sorry, this is 2. 2 over 9. So 2 times 4 is 8. 4 times 2 is 8. 16 plus 2 is 18. So this is a 2. Alright? That's why I realize it's not correct because we also know that EZ plus 2, I can get this by EZ plus 2, right? When I put my Z inside, then EZ is 0, then plus 2, so I have a 2. Okay? Then what about E3Z? E3Z from here, then you know it should be 0, right? But we also know that this is supposed to be 3Z times probability of the Z. So 3Z is negative 6 times 1 over 9. Then plus negative 3 times 2 over 9. Okay, 0. Then, because 3 times 0 is still 0, then 3 times 2 is 6, then 2 over 9. Okay, then this is 6, minus 6, then this is minus 6, then this is plus 12. So you have a 0. Alright? But theoretically, E3Z, I can take out the 3 and multiply with EZ, right? But EZ is a 0, so I have a 0. Okay? This is to verify that either way will do. If you need to find EZ plus 2, you can do like that. You can also do like that. Okay? Either one will do. Okay. Okay. Example 5.6. Let the random variable x have the probability mass function as follows. So this is 1 over 3 when x is negative 1, 0, and 1. But now, find the PMF for gx, where gx is x squared, and expected value of gx. Okay? Now, if my x is negative 1, then what is my g negative 1? When my x is negative 1, then what is g negative 1? 1, because negative 1 square is a 1. Alright? Then, when my x is 0, I get that x squared is a 0 also, right? So when my x is 1, my gx is 1 also. So that means my gx can only take 2 values. Okay? When I want a PMF, is either you give me in terms of table or you give me in terms of function like this. So you now know that my x can take value 0 or 1 here. But how can my gx is 0? How can my gx is 0? my gx is 0 when this is 0, right? Just now, x is -1, then this is 1. X is 0, then this is 0. When this is 1, then this is 1, right? Isn't it? Then my question is, my gx is x squared, right? So when my gx is 0, that means my x is 0, right? And when my x is 0, according to this, the probability is 1/3. So I have 1/3 alone. Okay? Now, how can my gx be 1? So it could be this or this, right? But this one, the probability is 1/3, and this one, the probability also 1/3. But this is this or this. So this becomes 2/3. And don't forget, you want to make things complete, then you have 0 else where? Okay. Then the question is, can I find E of Gx? E of Gx, according to the definition, is just the x multiplied with the probability, right? It's just 0 times 1/3 plus 1 times 2/3. So then this is 2/3. You look at it carefully, this is the same like the head just now, right? What's the probability of getting a head is 1/2. Then, here, how can I have my y is 0? Oh, I have head. The same go to here. How can my gx have an x is 0? My gx is x squared. So the square root of this is 0. That's why I have a 0. And I take their probability. So the same go for 1. How can the x squared get 1? When my x is -1 and or 1. Not and 1. Or 1. -1 or 1. So when this is -1, the probability is 1/3. When x is 1, then the probability is also 1/3. Okay? The difference is this itself, sorry, I should not put gx. Sorry, I should put f gx. This is, sorry, this is supposed to be f gx. Gx is 0 and 1 only. Okay. So maybe with that it become clearer. So now the same go for the hx. So if my hx is x, 3 minus x. Hx times 3 minus x. Then, yes. No, this is not a function. This is not a function. This is the probability. This is the PMF. This is not a function. Okay. This one, I can also write it as probability of Gx equals to 0 is 1/3. Probability of Gx equals to 1 is 2/3. Okay, or how can I get that? Why 2/3? This is probability of x equals to -1 or probability of x equals to 1. So probability of x equals to 1 is 1/3, and this is also 1/3. So that's why I get 2/3. Is that clearer? Okay. Okay, so sorry, because I thought you know. So then this one I could put it like this. This become probability of x equals 0. So that's why this is 1/3. That's why you get this. In terms of function, then we get this. Okay? Good. At least make it clear. Sorry, because to us it's a bit too straightforward already. We never thought further on that. Okay, now, if x is -1, 0, and 1, now my hx is x 3 minus x. So when x is -1, what is this value? -1 times 4, so it's 94. Then when x is 0, 0. So when x is 1, 2. Okay? Now, then this is very direct. So now, probability of hx equals to -4 is when my x equals to -1. Okay, maybe a bit fundamental when I put it this way. 1/3, x take value 91, 0, and 1. This means probability of x equals to -1 equals to probability of x equals 0 equals to probability of x equals to 1, and they are 1/3. This is the meaning of this function. Is it okay? Okay, so now if that's the case, how can my hx equals to 94? My x need to be 91. So my x is 91, so this probability is 1/3. Okay, then what about probability of hx equals to 0? Is probability of x equals to 0, and x equals 0, I have a probability of 1/3. Okay, at least this is clear now. Hopefully, Okay, not clear, then you better ask. Don't wait until last minute, please. So my hx can take value 2, and 2 is when my x equals to 1. And what's the probability? It's just 1 over 3. But my question is, please give me the PMF. So, therefore, the answer I need is f hx. Okay? So, when hx, so maybe I make it this way. Then this is hx equals to -4, and hx equals to 0, hx equals to 2. Then this is 1 over 3, 1 over 3, 1 over 3, and 0 elsewhere. Okay, now, then we look at function. Okay, now, isn't it when I have fx equals to x, I write it as fy equals to y. It's the same thing, right? So if I put fz, then this is equal to z, right? So now if that's the case, if I now put it as hx equals to 1 over 3 when my x equals to, what number just now? -4, x equals 0 is 1 over 3, x equals to 2, 1 over 3, and 0 elsewhere. And I tell you, this is a PMF. This also can, you know, because it's just like what we have just now, right? If your fx equals to x, then fy equals to y. They are the same thing, right? And if I want to call a function, I can call a function fx. I can also call a function gx, right? So that's why actually this one, nothing wrong, no? Okay, I just want to tell you that the answer that I gave you just now at the beginning with gx was actually correct. It's just a PMF. Okay, but then a bit confusing because it's PMF of gx. Okay? Okay, so I just want to tell you that that is also okay. Okay? And normally we use this one now. We seldom go by this one. And when you do process 2 at a time, then we will do this again. With more complicated thing. Okay? Okay, so now, what about E of Hx? Anyway, I need to go back and think about this again. How to get it more in a better way of writing. So this is 94 times 1 over 3 times 0 times 1 over 3 and 2 times 1 over 3. So I get 2 over 3. -4 plus 2. Yeah, it's a -2 over 3. 1. Nothing wrong with an expected value as a negative value. Probability cannot be negative. Expected value can be any number. Nothing wrong with that. Okay, 2. After you look at these two answers, do you think there is any relationship with the EX or not? No. Okay? You can try. Okay? So now, this is transformation, so no relation. So now there are two different casino tables, two different tables in a casino which offer different payoff in every $1 bet. So table 1 is payoff. Payoff is the thing that you get regardless of how much you pay at the beginning. Okay, so expected value of payoff is the average amount you expect to receive when you win without the initial pay or cost. We don't look at the cost. Expected payoff. So a little bit different from 5.8. 5.8 is net payoff. We talk about that next class already. Okay, so now that is the payoff in both table fair. So you want to know the payoff is fair or not, then you want to you are looking at whether they are having the same or not. So what is the expected payoff for table 1? Expected payoff is just the payoff times the probability. So it's 0.1 times 10. So we have 1. Okay, so table 2, we have expected payoff is 0.0001 times 10,000. So you get back 1 or so. So they have the same payoff. Then we will say the payoff in both tables are fair. They are fair, they are the same. Okay? So I don't want to start example 5.8 because I cannot finish in a short one. Okay? So we will continue on next Monday.